Hello, everyone. My name's Russ Fadel. I'm going to be the moderator of this panel on manufacturing and the use of AR, VR, and wearables. It's a 45-minute panel. We're going to divide it into 3 sections. At the end of each section, I'm going to open it up for a short question and answer period. So if you have some questions, feel free to ask them then. We will end the panel with a Q&A session. If we meet our goal, we'll be able to share our panelists' real-world experience in trying to deploy these new AR, VR, and wearable technologies into leading manufacturing companies, the experiences they had, the successes, some of the barriers, and the learnings they've had from their experience. So let's start. We'll start with some brief introductions. Everyone's bio on the panel is on the event website, so we'll start with a relatively short introduction so you can get a feel for who's up on the panel. I'm Russ Fadel. I'm currently the CEO of Augmentir. We're in the enterprise augmented reality space, about a 2-year-old business. Prior to that, I had founded a company called ThingWorks. If you're involved in Internet of Things, I was the CEO of that business. It's currently owned by PTC. And prior to that, I founded a company called Lighthammer Software, which was acquired by SAP. Okay, so we'll go from left to right. Chris Dockery, ergonomic specialist from BMW. Okay.
So I'm ergonomic specialist BMW. Been there 24 years. Background or training in ergonomics and human factors engineering. Been in the field about 30 years total.
Okay, and next is Janelle Harris. She's we just changed this, a human factors engineer at John Deere Company.
Yep, hello. So I'm a human factors engineer currently for operator stations at John Deere. I got my degree in biomedical engineering, which is odd for me to end up at John Deere, but I focused on ergonomics and biomechanics. So I was the ergonomics engineer for about 2.5 years in Dubuque, working on construction and forestry, and then the ergonomics engineer in the Quad Cities, working on our combine manufacturing line for about 3 years.
Great, thanks.
Check 2.
So William Hardin, a distinguished technical fellow at Medtronic.
So I'm William Hardin. I'm a distinguished technical fellow at Medtronic. Anybody who's not familiar with Medtronic, we're the largest in the world for medical device manufacturing, so pacemakers, neuro, cardiac, spinal. I presently lead Medtronic's Technical Fellows organization, about 405 people, and I also co-lead our extended reality, or what we call XR initiatives, which is an embodiment of AR and VR within different surgical and manufacturing environments.
Thanks, William. Luc Moseley, Senior Staff Engineer, Kohler Company.
Hi, good morning. So I work within the new product integration department within Kohler Global Faucets organization. I work within the new product development of showering valves, and when I'm not doing that, I'm implementing VR technologies for validating manufacturing systems.
And then finally, Andreas Oeder, he's the technical expert for human augmentation at Airbus.
Yes, thanks, Russ. Yes, Andreas Oeder from Airbus in Germany, in Hamburg, and I'm working since 2011 in the field of augmented reality. And since 2015, I'm taking care about the worker augmentation, so meaning introducing all technical and smart wearables to our workforce and to the industrialization.
Great, thank you. Okay, so we're going to start talking about real-world experiences with AR, VR, and wearables. And prior to the panel, I spoke with each of the panelists on the phone and found some interesting stuff. So we'll start with the topic of wearables. And in my sort of thought of wearables, it's my watch or smart glasses. But in talking with Chris from BMW, he has a completely different experience. I'd love to have him share that with us.
So in about the latter part of 2015, we started down the path of exoskeletons, fairly new at the time, specifically shoulder or upper limb exoskeletons. And we have quite a few out in our facility. And it's been a very interesting process. It's one of those, or like a lot of this new technology, you can easily end up with the beta camcorder version of things. If technology, if you try to run out there too soon, in my experience, and we did a little bit of that, but we homed in pretty well on it, and it was very interesting. We have about 1 minute cycle time for building cars, and so okay, that's fine. Well, if it takes 2 minutes to put on an exoskeleton and adjust it, we've lost 2 cars. We rotate 4 times a day, so now we've lost 8 cars per shift. So we actually ended up having to buy each person their own dedicated exoskeleton, leave it adjusted so that we didn't lose the time. Now, if you were building aircraft where your cycle time is 35 days, not really a big deal. So that's something we learned. We also learned that the job has to be bad enough. If it's just a slight discomfort for them or a minor fatigue issue, they may not be willing to put up with the putting it on and taking it off and the heat that's generated from it and the minor, pressure points and things like that. But if they're getting a significant amount of fatigue, and that's what we learned, is we had some jobs that we put them on that it wasn't really that hard. Their hands were up and down pretty quickly. And so they didn't develop a significant amount of fatigue, and therefore they didn't perceive the benefit. Whereas somebody who was painting a ceiling for a whole day would definitely perceive the benefit of those things. So we had to back up and say, okay, we need to find the jobs that are bad enough. It's a good analogy is if you want somebody to pick up a load, if it's 150 pounds, they're going to use a lift assist. But if it's 25 pounds, it better be slick or they won't bother. It's that kind of thing. So that's generally been our experience. We've been using the upper limb exoskeletons. We see opportunity for us in the back exoskeletons, and we're actually trialing a powered hand exoskeleton.
Yeah, so very interesting conversation, and so sure, open up the broader topic of wearables that are not smart glasses. Does anyone else have experience with wearables? Andreas?
Yeah, Russ. As you said, smart glasses are used, not fully introduced into our production systems yet, and we have still some problems with that. But we were thinking, what else can help us if we are not able to wear these glasses always? And so we said, perhaps audio instructions could be a good way forward and help us. And so we started to work with hearable technology, which we use today in order to give instructions or to feed information, speech to text, into applications. And the target at the end is really to see whether we can certify this hearable technology as ear protection. Yeah, so as everybody has to wear ear protection in the production environment. So we think it would be very good if we can combine these two things. On the one hand, the safety component, on the other side, the ability to either have some music, because this is a big issue in our production lines as well. So it's very loud. And in addition, our workers want to hear music during the work. So they put another level of sound into our production halls. And so we think it could be good to give them the possibility to hear music by their own and reduce the overall noise level in the production dramatically. But this is not all. So what we want is to have a clear way to communicate one-to-one or group communication enablement. And in addition, we can use this technology to communicate or interact with our artificial colleagues like collaborative robots or logistic AGVs. And so this is where we are working on, so step by step, iterative. We start with a device, we get permanent feedback from our first pilot users. The feedback is quite good. And so we go on and work with partners for the certification at the end.
Fantastic. Go ahead, Wim.
So we kind of approached wearables from a little bit of different direction. So when you think about IoT-enabled components and mesh-type configurations of data transfer or data aggregation, transformation of data, We characterized our wearables in the sense of what we call mixed reality. So mixed reality in our terms is you're not dealing with a display device, whether it's virtual or augmented, but you're dealing with a device that could be a data collector. And so say, for instance, one of the devices we developed last year is a wearable device. It's rechargeable. It's for detecting early detection of stenotic heart murmur. And as a way to take that data combined with maybe a motive that's picking up oxygen sensing, particulate counts from your Nest system, but taking these disparate systems and making more informed decisions with it. So if I'm a doctor's example wearing a headset like a HoloLens, I might be getting sensor data from the room, the environment, sensor data from the patient, the implanted device. So how do I use that to help me inform a better outcome? If I'm diabetes, am I taking additional non-medical sensors to help determine why I had an event if it's a type 1 diabetes? So when I look at mixed reality, it's really incorporating or aggregating or transporting data. And like our small ones are data aggregators for, again, making better decisions.
Yeah, fantastic. So we'll move on to a VR topic. And Janelle, maybe you can give the audience a more detailed view of your use case for VR in manufacturing and really how you chose that use case and why.
Yeah, so when I started with John Deere, I actually spent a few months working with the virtual reality group, which was an amazing experience and what really introduced me to this wonderful world. And primarily at Deere, up until that point, they had been using virtual reality, fully submersive headsets to analyze the cabs that we put on our machinery. And it's an extremely powerful tool. You know, we can show our customers, look, we're going to change this for you, or here's an idea, do you like it? Or work with our own engineers and say, where can we move the posts to increase visibility, things like that. And that has proved to be extremely valuable. But then after those few months, I took my role as the ergonomic engineer on the safety team, and then was in charge of our assembly and weld processes in the manufacturing plant. And if any of you have gone out on a manufacturing floor, there are some shocking things that you see. Things you would hope people wouldn't have to do to put together a machine. And so I kind of went back and said, you guys, there is a gap. Like we're thinking about our end users, which is amazing, and we should, but we're not thinking about our own employees. And we have this technology here on site. We have a VR lab on site, and we're not using it to better our own employees and to better their workspace. So, working on the safety team, the main thing that you're kind of thinking about is how do we reduce injuries or how do we prevent injuries? Well, VR was the perfect solution for that. And so I was able to say, you know what? We're going to start looking at our designs, not only for the end user, but let's look at the process. Let's look at the assembly process. So what I started doing was taking the engineers down to the lab along with the assembly worker from a specific station, maybe that was having an issue, and we could go through step by step the assembly process, either the current one or a proposed design change. And so they can go through and put in the bolts, use a torque wrench, go through each step and say, you know what, this posture stinks. The reach here is okay, this is fine. We were able to look at the postures, the biomechanics of the person. And through that, really, we were able to predict injury and then prevent it, right? So if in the VR lab, I see somebody, in order to reach a fitting that they have to torque, let's say, they're on their toes, arms fully extended above their head, using a 2-foot torque wrench that requires them to put out 150 Newton meters worth of force, something like that. We can not only say, well, that's a poor reach, he can't reach it, but I can predict, well, we're going to see a shoulder injury from this because that's a lot of force on one arm. And so we can change that and work with the engineers and change that design so that we can, one, prevent that injury, and then through that, one, you're increasing your morale of your employees, which they loved, but two, you're also going to see benefits for your quality and your efficiency, which are two other main things that manufacturing facilities want to see. If somebody can complete their job safely, that probably means that it's in a good position. The quality of it's going to go up. If they can reach it, it's just going to be better work. And then if they are in a good position to do so, they're going to be able to do it in a more quicker manner, you know? So we just saw huge benefits from that. And so I was able to do that in Dubuque with our construction and forestry equipment for about 2.5 years. And then when I moved down to the Quad Cities to work on combines, was able to establish a VR lab there and continue the process so that then we could reap those benefits for our combines as well.
That's great. Luc, I know you told me about some VR stuff you guys were doing at Kohler. Maybe you can tell me your experience and how it relates or intersects with what Janelle was just talking about.
Sure. So Kohler Company saw a need to improve our first time new product launches. We would see issues in process verification stages, or maybe even later on near the first production runoff. And so we saw using the VR tool as being very beneficial there. I would say Kohler follows a conventional product development cycle. And what I mean by that is as you move through the development milestones or the stage and gate process, getting closer to that first production runoff, you see a level or effort increase cross-functionally as you get closer to that, which doesn't really help mitigate against late changes, which are costly, obviously, with new product development. So we wanted to become more collaborative and have a lot more front-end loaded activity. And so we saw benefits with our China team of having 2 teams work remotely in 2 different locations, myself in the US and then teams in China, where we can immerse ourselves in a virtual world and make quick design decisions. Not only that, we saw improvements with quality. I would travel to China in the past and we would try and cram in two months worth of manufacturing deliverables in 1 week. So VR has now allowed us to have regular cadence with our manufacturing deliverables. And then lastly, we saw a reduction in travel. So that was really the big justification for us to spend money on getting visualization and VR equipment.
Very interesting. So Andreas and William, both of you have a pretty extensive experience in all forms of AR, VR. Maybe Andreas, your best example or example, does Airbus use VR in manufacturing or is it more AR?
No, in our case, we do both, but my experience is more in AR usage in manufacturing, so VR for trainings. So as I said, we started to use AR in 2011. This is when we introduced our own self-developed software on tablets first. So it was a software, or is still a software, which is supporting inspection use cases in large aircraft sections, and as well guided installation topics. Yeah, so we use industrial tablets for that and some marker-based AR solution then based on Unity. In 2015 then, we ported this solution to the HoloLens, and till now we have done several proof of concepts, of course, but we will have in October a first move into production in our new final assembly line in Hamburg for HoloLens and AR use case. So using the HoloLens 1, okay, it's not an industrial device at all. It's not fully integrated into our infrastructure yet, but it's bringing already a benefit to our workforce, and they are very happy to use it. And it's really reducing their time for their tasks, and they have fun at work. Yeah? And this is another factor which is important. With such devices and the early involvement of the workforce, we can bring a new level of fun at work. Yeah? It's, for me, one of the most important things we can bring with wearable technology.
That's fantastic. I have William, before we get to your thing, I wanted to do a quick poll. Mm-hmm. So a lot of companies I talk to do have a lot of VR and some AR development in-house, and a lot of them use different tools. How many use Unity as their development platform? Do you know what you guys use, Janelle?
Right now we're we're primarily using the Vibe, so we're working with HTC.
And I know you're doing exoskeleton, but I know you guys do VR at BMW. Do you know what primary tool you guys are using?
I don't. My colleague here does.
Okay. So it's interesting because, I do ask that question because we're in that same space. And, is there like a tool that you use internally? It seems to be obvious Unity is sort of the general market leader in the AR VR stuff.
Well, one thing to keep in mind, sorry about the mic, is there isn't a one-size-fits-all solution. And so when we think about, I'm not going to take a Oculus Go and put it in this environment where a Quest or a Rift 2 or Rift S will fit better, or something like a Vuzix. So we validate a lot of things, and we try to make sure it's the best fit. We're not trying to develop a solution to go look for a need. And so I think that's where a lot of mistakes are made. But in specifically to like Unity, am I using the Unreal? Am I doing things with Blender, any sort of Mesh Lab, Autodesk type tools, SolidWorks? Of course. There's different benefits to each one. They do become overly complex depending on how deep you get into them. But I don't think we should ever limit ourselves to one element. And I'll use an example to tie back to what we were talking about use of AR, VR in the workplace, is we don't take the mindset that this is the end solution, that it's using AR, VR. As an example, last week, literally, we approved a build for our Santa Clara EPIX line that's RF ablation. So if you have varicose veins or occlusion, this is the type of tools we're going to use for this. And in going out there, I used 360 capture with occipital 3D scanning, with a lot of range and infrared type concepts to pull in the content. I grabbed things that were literally dragged from our SolidWorks, put that all together, started preparing it to go through JigSpace for our cardboard city design, laid it out on the floor to say, yeah, this is going to fit. So what I'm getting to, it doesn't become your end solution. It's your design tool. It's your training tool that it keeps that design going. And anybody familiar with Cardboard City, I'm paying $30,000 a pop every time I engage people in a Six Sigma Cardboard City event. My JigSpace stuff, I'm doing an hour and a half. And I'm getting the same thing without dedicating a room full of scorpions in Arizona. But we're getting the same effects, and I can demonstrate it in an elevator to show exactly how the ergonomics and flow and how the haptic and non-haptic responses occur. So don't always visualize it, and I'm not saying anybody did it, but don't always visualize it as the end game. It could be the tool that helps you design new product, new layouts, and also offer the training, the onboarding processes and communications.
So it's interesting. In an early market, I think Chris mentioned that you don't want to end up choosing the Betamax in a VHS world. And Jeff Bezos had a really interesting thing. He said there are only two types of decisions in the world. When he decided to go out of New York City, he did it essentially in an hour. He says the hard decisions are one-way door decisions, which means once you go through the door, you can never go back. And he says most decisions in life are two-way door decisions. So you could choose a headset today and find out that headset manufacturer is out of business. The question is how much, what's the cost to switch back to something else? So it's a really interesting time, particularly in emerging markets where, the vendor space will change dramatically, either through companies going out of business or being acquired and product lines being deprecated. I mean, there's a lot of risk in early markets. So I think we've been on the topic for a bit, and so I'd like to open up the floor on VR, AR, and wearables experiences and see if there are any questions from the audience for the panelists. So if you have a question, just raise your hand and
I say if they don't ask, we pick them.
Okay. Sorry. We do it by badge number. It'll be a random drawing. Okay. Oh, up front. So yes.
Oh, sorry.
You were right behind the light, so you're coming out of the sun at me.
It's a halo.
Oh, hi, Chris. I would like to ask you on how do you calculate ROI on exoskeleton, because I have listened to a lot of people on the floor from yesterday and today on the difficulty is how to calculate that ROI in order to make a business case.
Well, we didn't. And because we were actually trying to solve a fatigue problem, just worker comfort, which inherently doesn't necessarily have an ROI. However, it depends. So if, for example, you were putting upper limb exoskeletons in use by somebody painting ceilings, you're going to reduce the amount of time they're going to need to take breaks to let their arms recover. That has value. If you're building aircraft and you're sanding the paint off the bottom of the wings because you're not allowed to use chemicals, so you have to do it by hand, you're probably going to reduce a lot of recovery time. So there's that part of it. We just completed a study, and I don't have the results of it yet, but it was a pretty solid one, where a PhD student came from Germany and actually measured the oxygen consumption of people wearing exoskeletons and doing the same task without them. And so we actually measure the physical benefit to the body of wearing the exoskeleton. And you could actually see it by task. There was a delta for each task. It was pretty clear. So we won't necessarily do that as a return on investment, but we will use it to help us tell where there will be significant benefit from it. If you're looking at a back exoskeleton where your torso weight is always there and you're bending over, it doesn't really even matter how much you're picking up. The torso itself is a significant weight. Then if you're lifting 10 boxes or 10 containers a minute, the fatigue factor will affect productivity. But I can't tell you at exactly what point you transition from fatigue to productivity gains. Our jobs are so easy that we were in the pure fatigue area, but there wasn't really a productivity gain. So for us, it was just goodwill for the employees. But there is a space, a problem space, whereby significant fatigue impacts their productivity, and there is a payback there.
So that kind of there's a broader question there, which is about how do you calculate return on investment? And also, do you need to have a proven use case before you start it with these new technologies, or did you use the technology and hope to find a benefit? So I'll go down the list here. Janelle, you first, and then on.
Yeah, I think I would say that I kind of sold it before I could prove the benefits. I just showed some of I did a couple just test VR studies and said, look what we can, the better positions we can put people in, look at how we're going to improve this worker, and look at the injury. This is the injury I predict based on XYZ or these circumstances, and we can eliminate that. So of course, when you're talking about new designs and injury reduction, your numbers are going to come later on. It can take 5 years to produce a new machine. So we'll see that return in 5 years. So the payback isn't instantaneous, or you don't see the payback right away, but it was pretty obvious.
So you kind of went on faith that it's like we will build and they will come. But That's great. And William, how about yourself?
Well, I agree with the fact that I think it also leads to our intuition, our instinct. We have a theory. It's the same reason anybody goes for a doctorate. You have a theory or something you want to prove. You may prove it wrong. So I think all the work will initiate from some sort of belief in our own intuition of how things will work out. But in our areas, and I'll use an example, we had a test equipment that if we remove 5 seconds from moving from this test equipment to our router, and there's a manufacturing hybrid boards for computers, and if we save 5 seconds off each step, we said, well, that's not significant. But when we started talking to the suppliers, the HR folks, and everything down the line, those 5 seconds, I had to triple check, were $10,528,000 of savings over a year period of time. And you started realizing, wait a minute, if I've just saved like 30K on my cardboard city, or I've made something where a doctor doesn't have to, you take a C-arm, you're x-raying a patient, put contrast material in, you can see where the heart is. That contrast material goes away, and now they've got to hopefully remember how to guide the catheter up there. But in the meantime, it's all dissipated. But if I were able to statically represent it in their field of view to help him with that guiding, like in a GPS, then I've just saved how much time of that patient constantly exposed to X-ray, carcinogenic contrast material. And then I think about the amount of reduced human error, but potential for infection. So when you look at that, it becomes really easy to see the use cases or the needs or the gaps in society. So I think our intuitions are spot on, and it helps guide us toward that direction.
That's great. Luc, I'll let you go, but sometimes in larger companies, it's hard to get things paid for with intuition, right? Sometimes you can't, there's no intuition budget. You know, there's an innovation budget, but, so Luc, please.
Yeah, I mean, I see it that you either sit in two camps, right? The first one is you have a CEO or executive that wants to be innovative and drive improvements through the organization with VR and AR. That really doesn't do well for sustainability for the frontline worker that's adopting the technology. You gain great alignment and you get the funding, but that's not so good with implementation, or it means sustainability. The other camp is the one that I was in, where I saw a vision and a business need for VR technology and visualization software, and found it very difficult to win the hearts and minds of our executives to get the funding for VR technology. So, yeah, I see it that you can be in one or two camps for that.
Andreas?
Yeah, so for us, it's, I would say, not always the same. It's really depending on the technology at the moment. With AR, we were lucky because we had a specific department in the past which was called AGI, Airbus Group Innovations, which were really specialized on the different new technologies at that time. And augmented reality was quite new, and we had a lot of experts on image processing, and they were working on that, and they found out, oh yes, we have such a technology, and they presented us to our production leaders, and they said, yes, this might help us a lot. Please develop a prototype, and then we do a proof of concept, and then we see if we go for it. And this was in 2010. But with other technologies like the rest of the wearables we did some years ago, yeah, of course, exploration first. What is on the market? What are the trends? What is possible very near time? And then we have done some benchmarks on some technologies like watches and glasses, and of course on our hearables. And then we have done a session with our workers. So asking them, okay, look, we have this kind of technology. We are thinking about scaling this in future. What are your pain points, and where do you think this technology might help you? So, and then we have prioritized based on the feedback from the workers, and so we are focusing on smart glasses and the hearable technology now.
Great. Is there a question?
So yeah, Mario Garza's here from Constellations. We make the wine, spirits, and beer that you all love. But so question is augmented reality, bringing the world where people have spreadsheets and they're looking at numbers and data on paper to the augmented reality of visualizing where that information shows up visually on a line. Tell me your experiences, or maybe difficulties of getting from that first stage to, is that a long journey, or can that, were you looking at vendors and kind of give me some idea how to get there, a roadmap that y'all took where applicable?
So anyone want to field that first one? The start, it's really, your question is, how do I go from sort of nothing close to AR to AR, right? So how do you make that leap? I think you give a lot of wine to your executives and you ask them for some money. I don't know if anyone has a comment on that.
Perhaps I can say something about this. It really depends on which information you want to augment at the end. So if you want to use really geometric information, so 3D data, clearly you have to have a very mature product structure. Yeah, in our case, it is needed to go down to the part level and feed as well information, so external metadata inside this product view. And due to that, we have developed our own preparation module, which is able to extract the 3D data, crunching it, simplifying it, adding external metadata on it, and creating the execution programs at the end. So this due to the fact that we had for most of our programs very good 3D data, except our main program, the single aisle. So it has been implemented in all programs except our most important one yet. So we have no augmented reality for single aisle today. But we are working on that, and we try to help here with other things to visualize, for example, 2D data, helping them with standard operating instructions, for example, in 2D format, and displaying this either on a tablet or in near future then on the smart glasses, if we have finally industrialized them and introduced into our infrastructure.
So maybe that's a great question. Maybe I'll just broaden that out and segue it into, what barriers to adoption have each of you run into? And then also, in talking with some of you, I did find there were some surprising learnings, like the fact that the jobs are too easy at BMW for the exoskeletons, and it's hard to change, and you can lose, 2 cars if you're just changing into an exoskeleton. And then I think related to that, I think it was what Andreas was saying at the end, and related to what William was saying, it's not one size fits all. Everything doesn't have to be a 3D model. Some things are most appropriate for 2D instructions, videos, et cetera. So if we go back down, starting back at this end, Chris, barriers to adoption and any surprising learnings. And our timing's getting a little short, so if we can sort of almost do a rapid fire round here.
So I think the biggest one that I run into, and I don't think a lot of people talk about this, is most companies want to know what the payback on the investment will be. They want a guaranteed payback. This is innovation. This is new technology. Sometimes we're trying just to see how it works. We do a pilot. That's what pilots are about. Corporate America, or corporations in general, aren't historically good at taking risks. They want guaranteed payback. That's what their financial processes focus on. There's a big difference between maximizing profit and minimizing cost. And we focus too much on minimizing cost. The way to do that, shut down the plant, sell everything, go home. If you want to maximize profits, you have to take risks, you have to try things. It's that lack of understanding that's been our biggest hurdle.
Interesting.
Yeah, I think in a big company like John Deere, or just any company that has been long-standing for years, one of the barriers you run into is, well, we've always done it this way, so why would I change? And obviously, we have innovation teams that are pushing, to avoid that. But sometimes when you get up to getting those approvals from upper management, that's what you run into. Well, why would I need that? And to your point on how do you implement augmented reality, if you figure it out, let me know. Because I'll be honest, I think that it would be great on our manufacturing lines for training and for, we don't have to look at either a book, which we've transitioned to a lot of screens, but still you're looking away from your work, right? And you're looking to a screen for your work instruction. And if you had it all just scrolling, that would be amazing. Safety managers don't love it, or at least my safety managers haven't loved it. They're worried about introducing a distraction, another hazard to the factory floor. And I think we'll get there. I really do, because it's inevitable. That's just how the world is turning right now. But it is a barrier. It's a major barrier that we face at this point.
Interesting. Hey, William, how about yourself?
Well, I was thinking of a simple statement, and my first thought was the barriers we were faced with is our perceptions of the value of what value resources represent. And specifically, we were talking to Lenovo yesterday, and they were saying some things around, oh yeah, when we got it to the IT folks or the quality folks, it just took forever. So, well, when did you engage them? Oh, we engaged them when the project was ready to roll out. Really? So when I started thinking about, if I'm looking at an IT or engineering or quality or a doctor or, the operations people or the user, I can walk out on the production floor, I can drop down what I want and tell them to use it. But if I'm going into a surgical environment, I've got to get the patient's perspective. I've got to get the sponsors, everyone involved. And I often see, as a guy who's in both hardware and software, that these perceptions of what is somebody with technical skill and knowledge and somebody can contribute is more a perception or a fault of the person who's perceiving the others. And in doing so, they're not including. If you look at Six Sigma and we're going to do DMAIC or DFSS, that's fine. But I think of what you were saying about human factors, you haven't started to consider the design or the people involved in that. You haven't brought in the stakeholders at an earlier phase. So when you're building things out, don't just think about technology assessment and adoption, sustainability, integration, deployment, end of life. These have to be considered, because otherwise you're going to hand it off to this group and they say, hey, my fault the IT guy didn't know how to do it. Did you include him in the beginning? No. So your perception of what is value is going to be your biggest barrier.
Yeah, good perspective. Luc, go ahead.
Yeah, so 2 barriers that we faced. The first barrier is upscaling our pilot, trying to expand the use of VR in other teams globally, and the thing that's obstructing us really is getting the funding. So I've committed to the business that we're going to improve our right first time metrics, but development cycles can be anywhere between, product development cycles can be 18 to 24 months in length. So I've got quite some time to show improvement metrics there. And the other barrier that we faced within VR is creating content. So we purchased a software that wasn't a Unity-based platform with the hope that it would be easier to generate content. And for the most part, it is to generate a scene. But when you want to do complex virtual assembly lines, it required coding and scripting, which our manufacturing engineers don't have that experience. So.
Yes, thank you. From my side, two points. On the one hand, I fully agree with Janelle because we faced really the issue that we had 2 projects. One was about Worker 4.0, bringing all the technology and presenting the technology, maturing it. On the other hand, we had an HR project, which is going in the Worker of the Future topic. And so what we saw, we have to combine this project to be very successful. So we made one project which is now about human success factors, really. And with this, we see we are much closer to the production people, and we have much quicker feedback about our solutions. And then regarding the upscaling of AR platform solutions, yes, this is really necessary and essential that for scaling that you have a valid platform approach, an approach on which you can start each new mixed reality application. This is what we are doing at the moment. We set up a platform which is including, for sure, mobile device management, preparation of data, the benchmarking of different devices, and see that this is all in line. Yeah, not in the past we had always bricks in all the different plants and divisions. Now we combine this, and this will bring us now to a quicker solution, quicker deployments.
Great. All right, so we're running out of time. I did want to ask about what we think the future is going to look like in each company, and I'm going to make it really simple. I'm blindsiding the panelists with this question. If you had to guess in your company, how much in 5 years are you going to spend as a multiple of how much you spent this year, will have spent the last year, in AR, VR, and wearables? Would it be 1 times, the same amount, twice as much, 5 times, 10 times? So just a single number. And I know there are some investors in the group who might be disappointed if the numbers are too low, so think big.
Well, I honestly think we'd probably spend 100 times.
In 5 years?
In 5 years.
Okay.
There's a focus on innovation. These things, they sputter. It's a weird thing. They go through this, they have interest, then the interest wanes, and then it keeps going and people have lost interest, and then at some point it just shoots up.
It's the Gartner, like it's in the trough of disillusionment, is that second phase, right?
Right, but it's still there,
But
and it
after
still
it's-
keeps going, and then it really takes off. And I think at that point, I'm guessing we'll be there.
Okay, we got 100x, Janelle.
I'm gonna stick close to what Chris said. I'm hoping around 100, and that would include exoskeletons because we could use that, including the AR, the VR, just all of that.
So I'm going to go from our current estimation of around $2 million that we've spent on some of the efforts right now and estimate based on what I know are budgets. So it's actually going to be pretty accurate. We'll probably spend closer to $200 million.
Okay, that's another 100x, and with real dollars associated with it. Luc?
I see with AR technology maybe about 50x. I see that AR will probably replace or be a strong alternative for automation systems. We're using it to improve quality yields, and I think AR will give us better flexibility. I think we'll invest more in AR than we will automated systems.
Yes. As we are upscaling at the moment and we are working on a platform approach, yes, I think our investment will really rise up. I think we will invest in the next times. I think first 3 times more than this year, but then it should normally decrease due to the fact that we have a stable system. So in 5 years, we expect to invest perhaps the same, but gain more success.
More success, more output.
Yes.
Well, that's fantastic. So I'm a venture-backed company, so those first 4 answers were just fantastic. I'll tell them it's 100x, 50x, and same with better output. But so we're really out of time, but I do think we have time for 1 or 2 quick questions. We're hard stop. All right, so obviously feel free to connect with any of the panelists or myself. If you have questions, I think probably if there's not contact information in the thing, you can probably find every one of us on LinkedIn. So thank you, everyone. Thank you, panelists.